So we're going to do graphing rational functions. So I don't think we didn't do the polynomial ones on the Mimeo, did we? I just did those for you. Okay. So we'll do these ones. So there's a couple things. There's properties of these that we deal with asymptotes and all that stuff because it's really fractions. So we'll get the easy stuff out of the way, the vertical asymptotes. Now you remember what an asymptote is, Bev? Yeah, it's kind of like a boundary, an imaginary line that a graph can never pass. Well, these will have them. There'll be horizontal asymptotes as well. So the vertical asymptote we get from our NPV actually. So it's where the denominator can't equal 0. I'm going to call it the line, but it's like a boundary. The line that a graph or equation can never, well, I shouldn't say never. There's situations where it can jump over it, but whatever. Can never cross. Okay, so where the denominator can't equal 0. That's messy. Okay. So let's do just a quick little example. It's kind of like the non-permissible values, right? I actually put that there. NPVs. So example, we'll do this one for a bunch of 5 over x minus 4. So if we were to graph that, one of the things we got to get all the asymptotes, so vertical to start with, then we'll get the horizontal. So in this case, it's just the NPVs, right? Because that's really where our denominator equals 0, can't equal 0. So x minus 4 cannot equal 0. So when I solve for x, I get x cannot equal 4. So that is our vertical asymptote as well. Okay, so vertical asymptote equals 4. So there's going to be a vertical line where x is 4 all the way up and down. Pretty simple. We'll keep that example. We'll go with that example all the way here for a bit. Okay, so I'm going to jump over now and we'll deal with the horizontal asymptote as well. Okay, now the horizontal asymptote it's kind of the same way, except if we go back to that question we just had, the y equals 5 over x minus 4, we had the denominator can't equal 0 for vertical asymptote. Well, if I take this x minus 4, hey Eddie, if I take this x minus 4 up there, and I get, no, just watch, because we don't do it this way, but this is why it is the way it is. So I get x minus 4, whoops, times y equals 5. And then I divide by the y, cancels that out. I get x minus 4 equals 5 over y. And then I add the 4 over and I get x equals 5 over y plus 4. Okay? Well, when we do all this, what can't y equal? Because we do the same thing where the denominator can't equal 0. Y can't equal 0. So in this case, the horizontal asymptote would equal 0. So because y cannot equal 0. So when we did the vertical, it was when y was isolated. Horizontal is when x is isolated. But we can cheat for horizontal asymptotes. And I'll give you some properties so that we can just know what it is. Okay? No, I wouldn't worry about writing that, but I mean you can. It gives you kind of why. Now, of course, this is just for when x is x. There's ones where x is squared. There's ones where there's an x up top in the you know, but beside the 5 and stuff, like it can get pretty crazy, and you gotta. So we kind of cheat. That's that way. I don't do it that way anymore. I'm gonna show you how to do it a quick way. So it's for this situation when x. When how did I word this before? Let's call it when your rational polynomial expression is equal to, let's call the top part, the top polynomial, p of x, over the bottom one we'll call q of x, okay? It doesn't matter what we're calling, we're just giving the functions a name, right? Now, we'll call it the horizontal asymptote shortcut, just the asymptote shortcut. Now you can use this forever and ever and ever and ever. Sure. So the first one, let's go with degrees. Okay, so I'll use the p of q as a higher degree than q of x and stuff like that. So if p of x has a degree that's less than q of x, so its highest exponent is less than that of q of x. Okay, so like the previous question, the 5 over x. Well, there was no variable with exponent. Well, there was, but it would be 0. And the bottom one had an exponent of 1. X to the 1, right? So that's this situation. The horizontal asymptote equaled 0. Always. Always going to be 0. If the top polynomial has a degree less than the bottom polynomial. Okay, so that's first trick. So that's number 1. Number 2, if p of x has a degree that's equal to q of x, then the horizontal asymptote is going to be equal to a over b. Okay, and I'll show you what that is here. Because we'll come up here, back up here. Better do this different color. P of x, we just say is x. No, I don't want to do that either. Let's click this. Where a is leading. And q of x is where b is leading. Numerical coefficients. Okay, and you'll see examples of that. Okay, where a and b are the leading terms. So if it was 5x squared over 2x squared, our horizontal asymptote would be 5 over 2. Okay, it's pretty straightforward once you see it. The only other possibility is if p of x has a degree greater than q of x, right? So it's less than, equal to, greater than. There is no horizontal asymptote. None. We just go to town. Okay, so we got vertical asymptotes, just the NPV, right? We've been doing that since the first. Horizontal asymptote, I follow these 3 rules all the time. Okay, because I showed you how if we isolated x, we're going to end up with this anyways. So rather than, and we know how to isolate x, so why? Let's just get to it, get working it. You don't even have to show work. You just, as long as you can recognize, hey, obviously it's 0. You'll see in the examples. coefficients. Boy, that's real nice.